All right, everybody. Hope everyone's having a good day so far. Just wanted to make a quick little video here, a little introduction to this video. This is going to be how most of your lectures are going to go for this class. As you know, we'll be doing the flipped classroom. We should have talked about it a little bit in class today. The way that this is going to work, we're going to go through and I'm going to show you a list of notes here. This is being done with our document camera here. So this is about how it's going to look. This isn't a computer screen or anything. This is actual, real life and stuff. So, if you hear the air conditioner going in the background, I apologize about that. I am trying to get somebody to let me have control over it so it doesn't interrupt my videos. If it doesn't, oh well. Alright, so a couple of things here. We're coming into calculus. We've already talked a little bit about what it's going to take going into calculus, what is calculus really. And so what we're going to get into here is going to be some basics of trigonometry facts. Now this is where we left off the year in pre-calculus. If you remember last year with your unit circle and all that stuff, we're going to revisit that some more as we go through a couple of our class periods. So this is where we're going to start the year off, and I'm going to go ahead and give you some information here. Now, you got this sheet actually in class. This will not happen all the time. Most of the time, actually, you'll just be taking notes as you normally would take notes. However, with this time, I went ahead and gave this to you because what you're seeing here is what you are going to keep throughout the school year. These trig facts are going to be stuff that you go back to constantly. A lot of it you'll recognize from last year. So we want to make sure that we give you a spot where it's going to be very easy to find, very accessible. We may even go through and see if we can laminate these. But for now, let's go ahead and get started with it. I want to make this as short as possible. So sine, most of you remember from last year that sine is the opposite over the hypotenuse, OPP over HYP. All right. We also remember that the hypotenuse in your unit circle, if you remember your unit circle, it looks something like this. You had your x value, your y value, and your r value. Well, your hypotenuse, or your opposite here, is the opposite of this interior angle. So it's going to be your y over r. All right, cosine is adjacent, ADJ, over HYP, hypotenuse. Right, cosine is adjacent over hypotenuse. That's going to be your x over r. Tangent is going to be opposite over adjacent. Most of y'all probably remember this. If not, we definitely need to get some remediation going on here. So we've got y over x, right? Now cosecant, again, most of y'all probably remember this. Cosecant, very simple. You just take your sine and you flip it. So instead of opposite over hypotenuse, you've got hypotenuse over opposite, which is going to be r over y, equal to sine there. We've got secant is going to be the reciprocal of cosine, so it's going to be the hypotenuse over the adjacent, or r over x. I apologize for my handwriting. Apparently I forgot how to write over the summer. Cotangent is going to be the adjacent, ADJ, over the opposite, or x over y. So again, most of y'all probably remember that. Let's keep trucking along. Your radians, sine, cosine, so going from radians to degrees. 0 radians is 0 degrees. Hopefully we all remember that from our unit circles. 30 degrees was pi over 6. This is just stuff we have to memorize. 45 degrees is pi over 4. 60 degrees was pi over 3. 90 degrees was pi over 2. Again, stuff we just have to memorize. The sine of 0 is the y value at 0 degrees. That was 0. The cosine of 0 radians, which is the x value at 0 degrees, right? The x value at 0 degrees is 1. Then we've got the tangent of 0 degrees is 0. Tangent being y over x, or 0 over 1, right? Sine of 30 degrees was 1/2. Cosine of 30 degrees was the square root of 3 over 2. Most of you guys remember this. Tangent would be the square root of 3 over 3. Now that was simplified from, if you remember this, 1 over the square root of 3. Remember, we had to multiply by the square root of 3 to the top and bottom, all that jazz. All right, so here, sine of 45 degrees, square root of 2 over 2. Cosine, same thing, square root of 2 over 2. Tangent is going to be 1. If you put that y over that x, you get 1. It's something over itself. You guys know that. 60 degrees here, we got the sine of 60, square root of 3 over 2. Cosine, square, ooh, goodness. Thank goodness this pen's erasable, huh? Got ahead of myself. 1/2, excuse that. And then the tangent is the square root of 3. Go to 90 degrees, which was that straight vertical line, straight up and down. If you remember, the 90 degrees on your unit circle was going up to here. So you're looking at this point. So for 90 degrees, your sine, your y value was 1. Your cosine, x value here, was 0. And your tangent, now your tangent is y over x. If we have this y over this x, that would be undefined. If you grab a calculator real quick and try and hit tangent of 90 degrees, it goes crazy and spits out an error, right? All right. So let's go down here into our fundamental identities. Now, all of this stuff was covered probably within, I would say, 1 day, or excuse me, 1 week in calculus, or pre-calculus. We're covering it in 1 day in calculus. So we're going to get all this figured out here. We've got, let me go up a little bit here. We've got cosecant of theta. Remember how we identified cosecant was 1 over sine of theta. Secant is 1 over cosine of theta. I gave you a sheet last year that had all of these identities printed on it. Remember, an identity just means that these two things will always be equal. That's why they call it an identity. Tangent is going to be sine theta over cosine theta, or you could write it as 1 over cotangent theta. Therefore, cotangent theta would go, if you kind of extrapolate that, it'd be 1 over tangent theta, or cosine over sine. Cosine theta over sine theta, right? Sine squared plus cosine squared, everybody's favorite identity, all goes to 1. 1 plus tangent squared theta goes to secant squared theta. 1 plus cotangent squared theta was cosecant squared theta. All right, those are your fundamental identities. All of those can be derived from just looking at one identity and kind of expanding it from there, substituting in, going back, expanding, all that stuff. Double angle formulas. Sine of 2 theta came out to be 2 sine theta cosine theta. Cosine 2 theta came out to be cosine squared theta minus sine squared theta. And if you remember this one, it was actually the same for 3 different identities. It actually had 3 things that it was equal to. So I'm going to write all 3 here. 1 minus 2 sine squared theta, or finally here, 2 cosine squared theta minus 1. I'm sorry if you can't see that. It's 2 cosine squared theta minus 1. Alright? Again, all we're doing is just writing down. We're not going to take the time to derive all of these because we did that last year. We don't need to take time for that. It's calculus. Alright. So a little bit of your non-calculator review here. Non-calculator review, you're solving for everything between 0 and 2 pi. 0 to 2 pi, if we look at cosine of theta is negative square root of 2 over 2. What we would think about here is where is the cosine, where is the x value of our unit circle going to be negative square root of 2 over 2? Well, if you think about that, we've actually got 2 places where that's going to happen. You look at where is your x value negative, second and third quadrant. That happens to be at 135 degrees 225 degrees. Remember, it's your 45, 45, or all your 45 degree measurements, your 45, 45, 90s. Right, and if you write those as radians, you can go through and do that as well. 3 pi over 4 and 5 pi over 4. Where is tangent 1? So if you put your y over your x, where is it 1? Well, that happens again in a couple of places. 45 degrees and 225 degrees. Also known as pi over 4 and 5 pi over 4. Where is sine theta? The square root of 3 over 2. Right? Sine theta is the square root of 3 over 2. You're looking at the y value here. So again, you're looking for where is sine going to be positive. Well, you got two quadrants where sine is positive, your first and your second quadrant. Where is your y value positive? Going up. All right. Reference angle here, square root of 3 over 2, it's 60 degrees. Very simple. You can actually pick that one out straight from your table up above. The sine of 60 is the square root of 3 over 2. So one of your angles is 60. The other angle is going to be the reference angle in the second quadrant, 120 degrees. That's going to be pi over 3 and 2 pi over 3. Cotangent being a negative square root of 3, that cotangent is negative in quadrant 2 and 4, right? Quadrant 2 and 4. Your reference angle there is going to be 30 degrees. So you've got 150 degrees since you are going in a negative direction, and 330 degrees. And just for the sake of time, if you want to go back and look at if you want to go back and look at the radians for those, you're more than welcome to do so. Alright, now for the last bit here, I'd like you to go ahead and do the 3 decimal places on all of these. Make sure that you are in the correct mode. Since you're dealing with pi, your calculator needs to be in radian mode. And I really want to take the time to do this. You're welcome to. We'll check this once we get back into class. I'm going to have y'all compare your answers. That's the front page. So we're going to continue that, and we're going to go into some inverse trig functions. Alright guys, just wanted to kind of continue on here. We're going to start talking about inverse trig functions. Now, one thing that we didn't really get to talk about last year very much was the actual graph of these sine and cosine functions. Now, if you remember from your unit circle, we always start off measuring at 0 pi. Let's talk about radians here. Over here, if we follow this direction, we get to pi radians, right? Back over here, we get to 2 pi. And if we wanted to, we could keep following to 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, on and on and on, right? What this actually does is, if we're talking about your sine values, we're talking about the y values here. And if you're looking at the y values here, your y value is 0, right? The point here is whatever this x is, comma 0 for y. Up here, your point is 0, comma 1. If you remember that this is actually going through the origin here. So this is actually 0, comma 1. So the sine value goes from 0 to 1, back to 0, to negative 1, back to 0. So if we were to graph that, what would it actually look like? So here's what I'm going to do. I'm going to go to my handy dandy calculator here. I'm going to type in sine x, and I want you to hit graph. And what you're actually seeing is the sine graph. Now I'm going to do a little stuff here with my window. I'm going to go from 0, and the max I'm going to set it at 2 pi. Alright, my y values don't need to be this big. We'll change them to -5 and 5. And what you're actually going to see is one cycle of the sine value. So remember, we said that when your value is 0 here, starting off, it goes from 0, right? Traveling around the circle, it goes up to 1, right? And then it goes to pi, or then it goes to 0. So when your x value is negative pi here, for example, or positive pi, you're looking at a value of 1. Or excuse me, a value of 0. I'm sorry. All your pi's are going to be 0. Let's take a look here. On this graph, if you notice here, you're going up 1, 2, and I wonder what that could be. Let's find that real quick. Let's find that 0. Left, right, 3.1415. Kind of sounds like pi, doesn't it? So you can imagine what this is doing is it's just kind of going through the cycle this way. It's going and going and going, and then it's plotting the values on an XY axis. That's really what's happening. Alright? So if we think about this, we can kind of standardize our window here. Let's say we want to go from -1 to 1. Why? Why not? If you can kind of see what's going to happen here with these, or I'm sorry, let's change that up. I'm sorry about that. Let's go from -pi to pi. We can also get one cycle of the sine wave here as well, going through the origin, perfectly split. So what we're going to do here is we're going to kind of take on that same function, but now let's talk about the inverse. What is the inverse going to look like? So we have the inverse down here, second sine of x. Alright, so now what's happening is we are taking our xy values and we're flipping them. But what happens after this point? Well, the principal values for the range only go from a -pi/2 to a +pi/2. See, negative sign is only defined between -1 and 1. Between -1 and +1. Alright? So let's actually get into the notes here and let's talk about what this is actually going to mean for us. You have this. So let's go down here. We're going to draw this picture of the arc sign here. We'll get into more of this as we go on throughout the year. Trust me, this is just a brief introduction. All right? Excuse me. So we have, here's 0, right? And basically what I'm going to do is I'm going to graph the arc sign. Oh gosh. I'm going to graph the arc sign that I just graphed on my calculator, but I'm going to graph it on here. 1, here, and here, and here. We'll call this pi. This will be pi/2. This will be -pi/2, so on and so on. Now, if you notice what actually happens here, it goes down to a -pi/2 when your x value is -1. Flips up, comes through the origin, and then goes up to where your values are 1, pi/2. Alright, this is the arc sign, or the inverse sign. Those two terms are interchangeable there. Alright, so the principal values for the range go between -pi/2, right here, and pi/2. Why? Because what happens after that, if you think about changing the xy values, you're going from, I can do this over here, you're going from a graph that looks like this to a graph now that looks, or I should have put that, let's change that up here. Let's try this one more time. You're going from a graph that looks like this to a graph now that is going to look like this. You're flipping the x's and y's. Well, this squiggly line right here makes this not a function. So in order to be a function, we have to restrict it. We have to cut this thing off. If you want to make this thing a function, you have to restrict the domain so that it is a function. So we're going to go from -1 to +1. That's the only way that this thing could actually be a function. Same thing for the cosine. I'm going to try and hurry here. This is just meant for mainly definition, and we'll kind of go through and explain more of that a little bit later. Let me give you an image here to look at. Alright, so first, cosine of x. Now this is going to be the same the same pattern as sine, but just like on your unit circle, right? When you're given an x value, like when you're given the value for, let's say, 0, right? When your x value is 0, what was your y value? Well, your y value was 1. You're talking about your unit circle here. So this cosine function has a different period. It starts over a different domain as far as your maximums and minimums. So here's the cosine function, right? Let's go back in here. Now the inverse cosine, or the arc cosine. Now again, if you notice, it restricts it from -1 to 1. The reason for that is it has to be defined as a function. It has to be defined as a function. We can't have this as a non-function. Alright, because we are talking about the inverse cosine function. Alright, so here's -1, here's +1, 0, pi over 2, pi, right? Now if you notice, this goes through pi over 2, comes down and hits 1, goes up and hits where -1 and pi meet. It's a little off, but forgive me for that. And it hits where they meet. Now those are the cosine and the sine inverse functions. So the inverse of sine, the inverse of cosine.